Welcome to Lesson 2, Part 1. This is on in behavior and multiplicity, and mainly it's going to be about in behavior. So when you're looking at in behavior, you're looking at actually what happens at the ends of the graph. So we're ignoring all of this, so just for a moment, ignore all the maximums and minimums that we've been talking about previously. So just ignore this part, and we're just looking at the far left and the far right of the graphs. So if you look at the far left portion of each graph, you're looking at as x approaches negative infinity. So if I'm looking at this end, I'm looking at x as it approaches negative infinity. So when we're talking about in behavior, we would say as x approaches negative infinity, f of x, the function, is approaching positive infinity because it's going up to positive infinity. If I look at the right side of the graph, I would say as x is approaching positive infinity, because here my x values are increasing, f of x is approaching, it's going up, so I know it's going to positive infinity also. If I look at the second one, as x approaches negative infinity, because it's going to the left, f of x approaches, again, it's going up, so I know it's positive infinity. If I look at the right side of the graph, as x approaches positive infinity, because it's going this way, so my x values are increasing, I see that the function is approaching negative infinity because it's going down. So you try the last two and then check your work. Okay, here is another example for you to try. So pause the video, try the work, and then check it. You can see that both in the first one they're going up, up, and so that would be positive infinity, and notice I have two answers with positive infinity. This one is an up and a down, so it's a positive and a negative. This one is down, up, negative, positive, down, down, negative, negative. So what is the in behavior of these standard parent functions? So if you look at, here is the parent function for a linear, and the degree of a linear is 1. And I notice that one end is down and one end is up, so negative infinity, as x approaches negative infinity, the function approaches negative infinity. As x approaches positive infinity, so does the function. If I look at the odd one, another odd one, here the degree is 3, which is odd. Notice that the number 1 is odd, the number 3 is odd, and they're going in different directions, the in behaviors are. So as x approaches negative infinity, so does the function, and as it approaches positive infinity, so does the function. Okay, let's look at these. They both have even degrees. So the degree here is 2, and that's an even number. The degree here is 4, and 4 is also an even number. Well, if I look at an x squared function, looks something like that. It's a U-shaped, and as x approaches negative infinity, the function approaches positive infinity. As the function approaches, or as x approaches positive infinity, so does the function. It's up, up. If I look at an x to the 4th, it looks something like this. Remember, it's a little flatter along here than I probably drew it. But regardless, the end behavior is up, up. So I know it's positive infinity, positive infinity. So just make note that for odd degrees, they're going in opposite direction, and for even degree functions, they go in the same direction. So, and here's where you can fill this in your notes. What do you notice about odd degree functions? The ends go in opposite directions. So one's up, one's down, and one's up, and here it's the opposite. So this would be a function that has a positive lead coefficient, but it's odd degree, and it has a positive lead coefficient. This one is also odd because they're going in opposite directions, and I know it has a negative lead coefficient. What do you notice about even degree functions? And that's that the ends go in the same direction. For this one, I know it's even. I know both of these are even degrees. So that means the highest power is an even number. And for this one, because it's up, up, I know it has a positive lead coefficient. I know this one has a negative lead coefficient because it's reflected. Think about the end behaviors of these functions. So we're looking at this one, and you're going to ask yourself, is the degree even or odd? So I'm looking here, this is a 3, so that's odd. And what about the lead coefficient? So here's my lead coefficient, and I'm told right here that the lead coefficient is greater than 0. So I know I'm going to be looking at something like this. Okay, as x approaches positive infinity, what is the end behavior of this function? So I know it's going to be that as x approaches positive infinity, the function is going to approach positive infinity. Because I can look up here at that top one and know that's my pattern. So this one, again, you're looking at, is it even or odd? And this one's even because the number 4 is even, and that's our highest power. And we're told that a is negative, so our lead coefficient is a negative because it's less than 0. So I know this one's going to be like this and be down, down. So as x approaches negative infinity, it means that f of x will also approach negative infinity.